Sai Ram children, good morning. Welcome to online session. So we'll continue with our chapter 1, rational and irrational numbers. So let's revise what we have learnt in the previous session. We have learnt about terminating decimal form and non-terminating recurring decimal form, right? Okay, so now here state whether the given statements are true or false. Now it is based on, that is what we have studied in the previous session. First question. So you all are ready with your books, right? You have to write only answer. First question is 0.42857 dot. It means it is continuing. Is equal to. So how it is written as 0.42857. Again the same number is recurring, that is same digits, 42857. So what we do? We put a line above those digits, that is we call it bar. So it is 0.42857 bar. It is an example of a terminating decimal form. Yes children, we have studied this previous session, that is terminating and non-terminating. So it is an example of terminating decimal form. Answer is false. Answer is false. It is an example of a non-terminating recurring decimal form, right? It is non-terminating. Dot. It is saying non-terminating, and recurring, same digits are recurring. Okay, so the answer is false. Next one. A terminating decimal form can be written as a non-terminating recurring decimal form. Yes, what is the answer? Terminating decimal form can be written as non-terminating recurring decimal form. Yes, answer is true. And we have seen the example also. For example, if it is given 3.5, then second decimal place, third decimal place, we can go on adding 0. Example is 3.5. So it is also same as 3.50. 3.5000. So that way. So what we do? 3.50 and we put dot above it to show it is recurring, right? So this example, this sentence, that is terminating decimal form, can be written as non-terminating recurring decimal form. It is true. Now let's learn. Okay, now in addition to rational numbers, there are many more numbers on a number line. We have studied the rational numbers, the numbers which can be expressed in the form m upon n. M and n are integers, but n is not equal to 0. Denominator is not equal to 0. We have studied this, that rational numbers. Okay, so now in addition to rational numbers, there are many more numbers on a number line. They are not rational numbers. It means they are irrational numbers. The numbers that are not rational are irrational numbers. For example, it is given here root 2 is such an irrational number. So root 2 is irrational number. Now the decimal form of an irrational number is non-terminating and non-recurring. So what are irrational numbers? Irrational numbers are the numbers whose decimal form is non-terminating, non-recurring. So their decimal form, the division doesn't end also, and it is non-recurring. So remember, non-terminating, non-recurring. For example, here example is given 3.417219 dot. It indicates that it is continuing. Now, is there any digit recurring? No. 172, again 1 is given, but the next digit is 9. It means it is non-recurring, non-terminating. It is an example of irrational number. Even pi. Now pi. Where we have studied about pi? We have studied about pi in area of a circle. What is the formula to find area of a circle? It is pi r square. And also we have studied about circumference. Formula to find circumference is 2 pi r. So pi is an irrational number. But for calculation purpose and all, we take pi as 22 upon 7 or 3.14. So 22 upon 7 is a rational number. Even 3.14 is a rational number. But pi, when we say pi, which is a Greek letter, it is an irrational number. So it is an example of irrational number. Even root 3. Now root 3 is an irrational number. So root 2, root 3 is an irrational number. Now what about root 4? When we say root 4, you can solve. What is the square root? That is square root of 4, it is 2. And 2 is a rational number. So when it is asked to root 4 is a rational number. Because 4 is a perfect square. So numbers which are perfect squares, their roots, okay, they are rational. Root 5. Now root 5 is irrational. Root 6 is an irrational number. Root 7 is an irrational number. Root 8 is an irrational number. What about root 9? Root 9 is 3. Square root of 9 is 3. So when we say root 9, it is a rational number. Okay, so remember that the decimal form of irrational number is non-terminating, non-recurring. Okay, now real numbers. Now what are real numbers? The numbers which can be shown by points of a number line are real numbers. So when we draw the number lines, we have learned to show rational numbers also on a number line, right? So the numbers which can be shown by points of a number line are real numbers. Now all rational numbers are called real numbers. All irrational numbers are also called real numbers. So we will also learn to show irrational number root 2, root 3 on a number line. We will be learning. So remember, all rational numbers are called real numbers. All irrational numbers are called real numbers. Because real numbers we can show on a number line. So all rational numbers and irrational numbers are together called real numbers. So we will also learn to show the number root 2 on the number line. We know that root 2 is an irrational number. So we will learn to show irrational number 2 on root 2 on the number line. So this is root 2 and we will learn to show root 2 on a number line. We will learn to show the numbers root 2 and root 3 on the number line. Take ruler and pencil and draw a line. So draw a straight line. As it is a line, draw arrows on both the sides. Now mark the numbers O, that is origin 0, and we will mark the numbers, that is positive numbers and negative numbers. Now for marking the numbers we are taking 1 unit distance, and that 1 unit distance is equal to, we are taking 3 centimeters. So do the marking on both the sides. So here also that is 3 centimeters, but it is our 1 unit distance towards the left, towards the right. Now the numbers towards the right are positive numbers. So 1, 2. So we have to show only 1 or 2 numbers. Don't show more numbers. And left side negative 1, negative 2. So after showing the numbers, we will write the scale. And 1 unit distance. It is our 1 unit distance which we have taken as 3 centimeters. So scale is important. Even scale is important, you know, in maps and all. Graph. So always we have to write the scale. We have written the scale. 1 unit distance is equal to 3 centimeters. Now we will take a protractor. Okay, before that you have to mark the point A. Point A shows the number 1. Remember. So the important numbers we are marking. So 1 is point A. Now take a protractor 90 degree. You have to draw perpendicular to the number line. Through the point A. You have to draw perpendicular to the number line through the point A. So perpendicular, that is 90 degree angle. So 90 degree angle, show the marking of 90 degree. A is our right angle, so show that marking. Now 1 unit distance. 1 unit distance is nothing, this is OA. OA is 1 unit distance, and that is our 3 centimeters. So that perpendicular, you cut at an arc, that is at 3. Draw an arc at 3 centimeters. This is our unit distance. Remember, this is our 1 unit distance. Now draw the point segment OP. Draw the segment OP, that is join the points O and P. Now with your compass, OS center and OPS radius. O is the center, OPS radius. Draw an arc. So draw an arc and it will intersect the number line. Mark that point. It is intersecting the number line and we have to mark that point, and that number is, yes children, which number it is? It is our unit 2, that is square, that is root 2. It is our root square root, that is root 2. So now if I take same distance to my left, it will become negative root 2. So OQ, distance OQ is root 2. OQ is root 2. And if I will take to my left, it will become the negative root 2. And that negative root 2 is shown by the point B. Negative root 2 is shown by the point B. Okay, now triangle is formed. You can see OAP, a right angle triangle. Now we will see the explanation. And the explanation is in triangle OAP. You can see the triangle is formed. Measure angle A is 90 degree. Now if A is 90 degree, our hypotenuse is OP. So OP square is equal to OA square plus AP square. It is hypotenuse square is equal to side 1 square plus side 2 square. Now our OA is also 1, AP is also 1. So 1 square plus 1 square. Now square of 1 is 1. So 1 plus 1, 2. Our OP square is 2. That is our OP square is 2. Taking square root from both the sides. OP is root 2. So distance OQ is root 2. Point Q shows the number root 2. It shows the number root 2. So this is the way we have to draw root 2 on the number line. Now for root 3. For root 3, same procedure we have to follow. But now we will be drawing the perpendicular on root 2. We will keep our protractor on root 2. Center of protractor, that is on point Q. That is our root 2. Now with the help of your ruler, draw a straight line, that is our perpendicular. So for root 3 also we have drawn perpendicular. But now this perpendicular we have drawn on the point Q. Now same unit distance, and 1 unit distance is 3 centimeter. 3 centimeter is our 1 unit distance, that is OA. That is our 1 unit distance. AP 1 distance, same way, same distance we will do, and we will cut that perpendicular, that is draw an arc at the 1 unit distance, and we will cut the arc, we will name that point. So name the point R. So QR is 1 unit distance. Now draw the points, that is draw segment OR. Join the points OR. Again what we will do? OA center, distance OR. Cut the arc which will intersect the number line. Cut the arc and it will intersect the number line. Now where it is intersecting the number line, mark that point. That is root 3. That is our root 3 and is shown by point C. So root 3 is shown on that is point C. So this is the way to draw root 3. So for root 3, draw root 2. For root 3 also, we have to draw first root 2 and then show root 3. Let's start with practice set 1.4. The number root 2 is shown on a number line. Steps are given to show root 3 on the number line using root 2. Fill in the boxes properly and complete the activity. So here one activity is given. This activity is nothing but the explanation of root 3. Its construction we have seen. We have seen how to show the number root 3 on a number line. But its explanation is nothing but the activity of this practice set 1.4. So here it is given the number line, and this number line is showing the point root 3. Number line is showing the point root 3. Point C shows the number root 3. And we have also seen that root 3 is, that is for root 3 also you have to show the point root 2. So remember that if you have to draw root 3 also, first you have to do root 2. On root 2 we will be drawing the perpendicular, and then OR is radius. This is root 3. So this all construction we have seen, right? So this is root C, and this explanation is of that construction. Okay, now this is the activity. Point Q on the number line shows the number dash. So you have to see here point Q. So see, this is the point Q, and this point Q shows the number root 2. So the answer is root 2. The point, that is Q on the number line, shows root 2. So this is root 2, right? Point Q is root 2. Next, a line perpendicular to the number line is drawn through the point Q. So this point Q which shows a number root 2, and on that Q perpendicular is drawn. Point R is at unit distance from Q on the number line. So we have seen what is unit distance. Unit distance is 1 unit distance, what we have taken as 3 centimeter. So this is nothing but a unit distance. So point R, we have shown that arc is taken, that is at unit distance from Q. Now right angle triangle ORQ. So here this is a right angle triangle ORQ is obtained by drawing segment OR. So when you are drawing the segment ORQ, this triangle is, right angle triangle is formed. Now length OQ, this is a length OQ, and this length OQ is root 2. So length OQ is root 2, and length OR, this is your OR, this is 1. We have seen that at unit distance we have cut the arc. So remember this, children, that OQ is root 2 and OR is 1. By Pythagoras theorem. So what is the Pythagoras theorem? Hypotenuse square is equal to side 1 square plus side 2 square. Now here your hypotenuse is OR. So it is given OR square. OR square is equal to OQ square plus OR square. So OR square, hypotenuse square, is OQ square, side 1 square, and your QR square, side 2 square. Now OQ is how much? Root 2. Even here we have shown OQ is root 2. So this is nothing but root 2 square. Here it is nothing but root 2 square. And your QR is 1. This QR is 1. Now square of root 2. Square of root 2 is, yes children, root 2 square. It means root 2 multiplied by root 2. So root 2 multiplied by root 2 is root 4. So root 4 is nothing but 2. So root 2 square is 2. And square of 1 is 1. So 2 plus 1, the answer is 3. 2 plus 1, answer is 3. So your OR square is 3. Your OR square is 3. Now taking root on both the sides. So when your OR square is 3, taking square root on both the sides, your OR becomes root 3. So your OR becomes root 3. So remember, this point C is root 3. Okay, so this is nothing but the explanation of that this point C shows root 3. Okay, this point C shows root 3. So understood the how to show number root 2, root 3 on a number line. Even the explanation is that is nothing but justification. That we have justified that this is the distance root 2 or this is the distance root 3. So with the justification we have done the construction. So draw an arc with center O. So this is your center O. And this is we have drawn, that is draw an arc with center O and radius OR. So this is the radius OR. We are drawing the arc. Mark the point of intersection of line and the arc C. So this point C is nothing but the intersection of the line and the arc as C. So point C shows the number root 3. Point C shows the number root 3. So this distance OC is nothing but that is root 3. So point C shows the number root 3. Thank you children. Here we have completed our chapter. So you have to practice how to draw root 2, root 3 on a number line. So take good care of yourself. Sai Ram.